Today, we're going to explore a topic that doesn't always get the attention it deserves, but has a direct impact on product quality and long-term reliability. Welcome, or hopefully welcome back to Reliability Matters. I'm joined by Mehdi Nahali, founder of PCB Revision Control Pro. His platform is designed to replace spreadsheets, emails, and disconnected systems with a centralized approach to PCB revision lifecycle management and factory intelligence. We're going to talk about how revision control, data integrity, and process discipline impact reliability, and where manufacturers are still getting it wrong. And it all begins right now. Stick around.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Mehdi, welcome to the program. I'm so glad you're here today.
Hi, Mike. Thanks for being here, and thanks for this opportunity to talk about my software. I'm really glad.
Yeah, I'm glad you joined me. So just for my customers, my audience's benefit, I am in California. You are in Italy right now, so we're having a transatlantic conversation here.
Exactly. Yeah, so it's about 7 o'clock in Italy now.
Yeah, it's about 10 o'clock here. That's about right. All right. So, Mehdi, let's start with your background a little bit. What led you into electronics manufacturing and SMT process work? How'd you get here?
I've always been drawn to the intersection of precision and complexity, and the network manufacturing is exactly that for me. I started as also, let me say, an SMT technician, so 10 years ago. And I have hands-on estimate also, let me say, in Yamaha and Samsung SM for 71, for 82. What I loved about it also, it was also the combination of a technical depth, let me say, and the real world impact. Every board that comes off production line for me is very precise and also engineer.com. I was fascinated about that, and how much scale and knowledge goes into making also that happen consistently at the scale, let you say.
So you've spent a lot of time on the production line, and I'm assuming that you've seen reoccurring problems that just keep coming back. What types of reoccurring problems did you actually see firsthand that sparked the idea to solve that problem or those problems?
That's a good question. So, what attracted me most, how much time highly skilled engineers like us in SMT also spent on tasks that were fundamentally about data management, now, rather than engineering judgment. Also, before every production run, engineers in SMT also would compare BOM files manually and do the verification of the pick and place files too, and cross-check assembly drawing. These are more important, also those are important steps. They require expertise and attention. But the actual comparison work, going line by line through spreadsheets, that part doesn't require an expert, I thought. What if I could automate this also cycle, this comparison, so the expert can focus on the judgment, not on the counting, and spend time on comparing? That was also let me say, the most important thing, what I thought about.
Yeah. At what point did you realize that revision control and data management were bigger issues than most people realized?
When I start looking at how much time the revision of support actually consumed across a project lifecycle, Uh, from first design to production release, a significant portion of engineering hours go into managing, verifying, and communicating also revisions, BOM updates, and joint chance, PMP files, that's updates. Let me say also multiply that by a number of products the company also managed simultaneously, let me say, and you are doing, and so you are talking about a substantial portion of engineering capacity. I realized that if we could compress that time from hours to minutes, the productivity impact would be enormous. So that was the insight that led me to build this platform on this software.
Yeah, most people in that situation would complain that they don't like the way something's done. They might try and make it a
Yeah.
little bit better. They might come up with some ideas and pitch those ideas to management. You did something a little bit different. You said, I'm just going to rebuild the entire system. I'm going to come up with something that doesn't exist and replace the traditional methods of revision control. That is very entrepreneurial. So, what did your employer think about that? That you were, basically trying to scrap the existing method of emails and spreadsheets and all of that, and come up with something new. Did they support you? Did they uh, help you with that, or encourage you with that, or was it just something that you did kind of on your own as a side hustle?
Also, as I told you, my 360 degree of know-how in SMT and my experience also lead me to do that. How? Collaborating with my colleagues, my engineers, PCB designers. I've seen a lot of time they consume also to compare the bombs, also to pass from a version to another. And one day I said for the PCB designer and the engineers in my company where I work, I said to them, what if I create a software that make the automation of all this process? Like this, we can gain times and we cannot spend time, a lot of time also to compare all the versions of the project. Because where I work also, it's a famous company of automotive and they do also so interesting PCB boards and projects and they need a lot of precision and traceability. I said, why not? I did it. We try another way, more also, let me say, technological and automated it. That's it. They told me if you can do it, also we would be glad. Also, and my boss too. Also, he encouraged me to do that, and that's it. Also, I did it. I thought in 360 degree of in my company. I didn't thought just about myself. I thought about the designer. I thought about also the PCB designer, the electrical engineer. Yeah, and I release it. When I release it now, we are gaining a lot of time. When they want to make an upgrade, a hardware upgrade, they don't need to go back to the versions or the last bomb of etc. They just pick the bomb of the last version, new bomb, and then they can compare and see, and they can make a cross check between bombs, between pick and place files and bombs to see if the PCB designer is aligned with the electronic engineer. And by my experience, I have seen a lot of consume of time, as I told you, and a human error. Because sometimes the PCB designer or electrical engineer, they are not aligned. Also, the problem, I will see it me later in the production line. And I have to signal it to them. And by this way, I will also lose a lot of times. Also, PCB Pro revision is created to evite the human error and to speed up the process in SMD to make it so digital and more intelligent. That's it.
Now, the company the product that you developed, and the company that you developed. I was reading your website, and in the about section, you state that this is a one-man operation. You are the principal code writer, the designer, the architect, the business person, which is very impressive. So not every SMT engineer who can run a pick and place
Can do
machine
that.
and a reflow oven can also go back and write code, and set up a
Yeah.
business and a pretty cool looking website and all of that. Where did those skills come from? I mean, clearly you have them, but did you did you did you write
Basically,
code before you spent time on an SMT line?
also it's a work of 1 year. The architecture also of this software, I did it. I thought, what you say, and dreamed about it 1 year ago, and I said maybe why not? Also, if you release something like this, and I spent a lot of nights, let me say, that to architect at home, to study how to do that, how to do that. Basically, I'm an electrical engineer, but I studied to development, so I can develop softwares and something like this. And I'm not skilled, but I spent a lot of time to learn how to do that. So I finish my work, and then I go home and I start to develop till I finish it. When I finish it, everybody were also surprised. They told me, "You are you are genius. You did all that by yourself. As it's not something that someone did it by himself." I did it, and I thank myself and everybody that encouraged me to do that, because a lot of company before doing that, I asked them, and they told me we need it. So it's something interesting, and we need to digitalize the SMT department. I don't want to work any more classic. I want to more work also. I want now working with more intelligence, and let me say why not to putting AI in our process. That's my purpose now for the next also month, so the next year.
When people think about reliability, the show's about reliability.
Yeah, yeah.
Many engineers in our space will immediately think about materials, printing, placement, reflow profiles, cleaning, maybe box build, AOI, all that stuff. Where does revision control fit into that picture? It seems to be it seems to be way out of the main view of most engineers on a manufacturing line. That seems to be something a little bit nerdy that someone else always takes care of or should take care of. But talk about revision control and its impact on reliability or
That's
quality or
that's very
function, all of that.
that's very interesting question, because also revision control is the foundation that all of those other disciplines by learn. So the best of the past process, the most also precisely calibrated reflow of them, and the cleanest assembly environment. All of that delivers its full value only when the right design is being built. Let me say revision also control is what ensures the design reaching the production. Also floor is the correct approved version for me. And it's where the ability can also actually start, where the ability chain actually start, I can say it. Before materials are ordered, before components are placed, before the board also enters in the oven. That's it.
Yeah. I'm sure in your experience on the manufacturing floor, um, you've experienced real world problems with when revision control goes wrong. What are some
Yeah.
real world failure modes that can be traced back to poor revision control? Any examples of that?
So there is several examples if we say. So when a component is substituted, a different manufacturer for the same part having controlled BOM comparison ensures that so that the substitution is explicitly reviewed, that we say, and approved before it reaches the line, rather than discovered during the inspection. That's the purpose. And when a live change affects a critical net or ground core, a decoupling capacitor placement, a pixel level assembly drawing comparison catches it before assembly. Also, when a reflow to profile is adjusted for new paths and our profile analyzer validated also the new parameters against also the process window before the first board goes through. In this case, also the revision control system acts as a precision gate that protects the ability of the output, not the input.
How often
That's
let's quantify the amount of
Yeah.
issues um, that occur. How often do you see mismatches between bill of materials, pick and place files, assembly drawings? Is this a fairly rare event, or does this happen more than most manufacturers care to admit?
Yeah, as I said before, it can happen sometimes that so engineers they are not aligned in some way, and also PCB Pro revision control is so created for this way. It's one of the highest value also making these checks. Also areas in the transition from design to production. The PCB designer delivers, for example, a pick and place file based on their design data, and the engineering team has the bone. Okay, those two documents are created independently, and they need to be perfectly also synchronized between them, let me say, before the production starts. But under responsible production, our smart check feature also check, let me say, or automate that cross check validation entirely, comparing BOM, let me say, comparing also every reference designator and every component value, every package, every placement side between the two files. What user to require and experience it, let me say, engineer spending hour checking line by line. Now, with also my software, you can do it in just 2 seconds. You just put the two files and you can make the check
Yeah, that's great.
if they are allowed.
So your platform, your software, is built around replacing spreadsheets and email chains. The industry
Yeah.
has used spreadsheets and email chains for lots of years. Uh, why are those tools so problematic in modern manufacturing environments? What goes wrong with the old tried and true spreadsheets and communication via
Yeah,
email?
yeah.
What could
Understand.
possibly
Yeah.
go wrong
So,
with that?
so they are excellent engineered purpose, this classic way. Tools, but they were never designed for controlled revision, project, or management. A spreadsheet has no concept of an approved version. Also, anyone can open it, make change, and let me say, save it, and mail chain has no structured comparison capability. When you are managing a product with hundreds of components across multiple versions, the manual work of keeping those tools synchronized becomes a significant time investment. What we built, also, or what I built, it replaced that manual effort with automation. And so the engineer spends their time on engineering decision, not on data management tasks, so that the system can handle faster and more precisely.
Yeah,
And that's interesting.
clearly revision control is vital to ensure products go out properly. It's also important for traceability purposes. Um, how does the lack of traceability impact root cause analysis when something fails in the field?
How does the lack of traceability impact root cause analysis when something
Yeah, let's say something goes wrong in the
um,
field. they contact the
Yeah,
manufacturer and they go, Mehdi, what did you do wrong? And
yeah,
how does um, improved traceability help
yeah. Um,
determine what went
yes,
wrong or what
understand.
didn't go wrong?
Also, I can say, how does traceability support root cause analysis when product needs to be investigated? For me, it makes the process immediately faster and more precise. With a complete audit trail and the golden release package, which contains the exact BOM PMP program, assembly also drawing and reflow parameters that were released for that production. One, an engineer can immediately also reconstruct exact configuration of any board of any project. That precision means the investigation starts from the position, also from the position of certainly rather than re- reconstruction, let me say. And the time saved in root cause analysis alone is often cited by customers as one of the most, let me say, tangible returns on the software.
You recently introduced a reflow profile analyzer. First of
Yeah.
all, tell me what that is and walk us through why it matters. What are the
Mhm.
benefits of something like that? So let's start with what it
Okay.
is.
So profile analyzer takes a CSV file, as I told you, from any thermal profiler, and automatically also validate every zone of the profile: preheat, soak, also reflow, time above liquid or peak, cooling, and gas to pass, also manufacturing process window. In 30 seconds, it gives you the pass or fail of each zone, the exact value measured, and the 3-page PDF report too, ready for your process documentation or audit trail or something like this. What previously took an experienced engineer 30 to 45 minutes with also with a spreadsheet now happens automatically. You don't need that. With the same precision every single time for companies running multiple projects with different pass simulation specifications, sorry, the time saving is multiple across every production run, to say.
Traditionally, engineers manually review the profiler data, whether it's a kick system or a ECD or data pack or whatever. They're manually reviewing it. What are the risks of that approach of just having an engineer look at the profiler data versus having
Mm.
a package like yours analyze it?
The manual risk is consistency and time for me. Manual review requires an expert to interpret also the charts, calculate also the parameters, compare them to the process window, and document the results. The process is time consuming for me, and the results depends on the individual doing that, on the review, the experience also needed here, the available time that day, and the clarity of the profile output. Automating this also, it removes the variability entirely, let me say, and every profile is validated against the same precise parameter every time with the structured output that's immediately ready for documentation. Here also the engineer's expertise is still essential, but now for decisions, not for the calculation, as it do also the software.
Yeah. You describe your platform as factory intelligence, which is an interesting description. What does that mean in practical terms? Explain what your interpretation of factory intelligence is.
Also, yeah, it's intelligent for me. It's intelligent platform. It means that the factory has a structured, accessible knowledge about every product it builds. Every revision is documented, and every change is traceable. As I said, every release is validated and controlled, and all of that information is instantly available to anyone who needs it. An engineer reviewing the history of the product, quality manager preparing for an audit trail, or a new team member getting up also to speed up a project. Um to speed on the project. Also, factory intelligence means the institutional knowledge of your manufacturing process is captured in the system, not, let me say, scattered across email inboxes and shared drives.
Where do you see AI or automation having the biggest impact on electronics manufacturing over the next several years? I mean, AI is everywhere. It's ubiquitous now, and particularly within our manufacturing industry. Um, what's your prediction?
AI is already, I use it in my software too, as a, so you see in AI PDF chat, that's where you can put any PDF or schematics and you can talk with the system, with the platform, and they can explain you everything. But I'll ask about your question. I see AI in three areas. So first, intelligent change impact analysis. There we can put it. AI that can take an engineering change order and totally map it downstream impact across BOM. It's interesting too. Pick and place assembly drawing and the flow process. Also flagging everything that needs to be updated and reviewed. Secondly, predictive process optimization using historical profile and process data to optimize parameters that we say proactively rather than reactively. Thirdly, I see it too in design for manufacturer intelligence. That we say AI that can review a new bomb or layout and flag components or configuration that have historically correlated with production of challenges. Before the design is finalized, we are actively building also, let we say, I'm actively building also the first two in PCB revision control.
Are manufacturers ready for this shift into automated revision control, or are many still kind of stuck in the legacy workflows?
I think yes, the awareness is growing rapidly, especially among companies facing also increasing product complexity and shorter revision cycle. The challenge has been that the traditional tools for this, enterprise PLM systems, require significant investment and also a long implementation timeline. What I've built is designed to be accessible from day one. You don't need also Macs like other systems. A manufacturing team can be also operational on the platform within hours. I just install it and it's okay. It works.
Yeah. For companies that are not quite ready to adopt a full platform like yours, what are some immediate steps? What can they do now to improve revision control? I mean, obviously they could buy a platform like yours, but
Right.
before they do, what's your best advice for um, one positive step they can make to improve revision control?
For me, also three practical steps with no budget required. First, establish a single source of truth, one location, one naming convention, also that we say, one person responsible for releasing and approve it, also a version. Consistency that we say in how revisions are named and stored eliminates most version confusion. Secondly, implement a formal release checklist, I call it. Before any revision goes to production, a structured sign off that confirms the BOM and the template files and the assembly drawing, if they are aligned also on the same revisions. The single step significantly compresses the time spent resolving version questions at the line, I think. Thirdly, document your reflow process systemically for every production run and record the past specification, the profile parameters measured, and who validated them. That documentation becomes invaluable for process improvement and for any future investigation.
What should engineers and process owners start paying more attention to for tomorrow that might be overlooking today?
They must pay attention to areas. I think first the handoff from design to manufacturing. That moment when the PCB designer deliver files to the production team and assembly is one of the highest value points in the entire product life cycle. To invest also in structured validation and say systematic cross check between the BOM and the pick and place file as we talked before. Um, at that handoff, what our smart check also features does it automatically. Returns results of productivity per revision. Secondly, reflow process as a reliability inputs for me, and that's interesting. Most teams validate their profile visually and move on, but building a habit of systemic validation against the past, also process reflow, and documenting it for every production run transforms the reflow process from a variable into a controlled, documented also parameter. That documentation is the foundation of long-term solder joint reliability for me.
Is this a software as a service model, or is it a package that is installed on the customer's servers and run locally? Tell me what the architecture is behind the scenes.
Also, I have three also architecture of the software. I have also SaaS cloud, and I have a cloud manager, and I have air gapped on premises. So each client he can choose what he wants.
So, I'm sure in Italy there's an equivalent. In the U.S., we have ITAR, which is basically for military type work. It's a controlled flow of information, and a lot of times cloud-based stuff, unless it's a very secured cloud, isn't allowed. They like to see things kind of localized, within a siloed plant. So if your customers are facing something similar, that's possible. They can do a SaaS approach. They could do a local install edge approach or whatever. Both are available.
Of course, they are available. That's why.
Yeah,
So I've thought about that, and I created also,
you already
let
thought
me
of that.
say,
You've already
secured.
thought of that. Yeah, you've been there. Yeah,
Yeah, I know. So my software is also designed for the mass production companies like defense and medical companies, and I thought about them also to create a secured, let me say, software that you can run it on your server, your own server in the company.
yeah,
I can
excellent.
install it also
Yeah,
within hours. Doesn't take a lot of time like other software.
right. Are you still working at the as a SMT process engineer? Are you still on the factory floor, or is this consumed all of your time?
Of course, I'm always working. My work that's so I'm using my software now in my work. I am gaining a lot of time now. The designers and me, so we don't need to make revisions a lot also for hours. So we just when we want to make an upgrade for software for project for PCB, just also do it within hours. To say just the project I can do it in the day. Before it take about 1 week to upgrade also PCB now. In one day I can also product it. So I can put it in the production line. That we
Any?
can say with a bomb of three mines, with a bomb of 3 or 2050 and 500 also components
Well,
drop on board.
so are there future ideas in your head um, that for more software for more applications? Is this getting all your software creativity flowing here?
I'm focusing on also creating software in my also let me say, in my field, in electronic process engineering and assembly process engineering. I'm trying to optimize also the process and the time. And for me, that will be a big impact on also on any company that can also use a software like this. Because now time equal money. And for me, that software is time also reducing and the precision too and traceability. And all that leads to reliability too, as we talked before.
Excellent. Well, for my viewers and listeners who would like to get more information on Medi's software and solutions to revision control and reflow profile
Analyzer.
so I'm going to have to say that again, and reflow profile analysis. That information will be in the show notes. If you're watching this on YouTube, right down here where it says see more, look down there and information on Medi's website will be there. The URL will be there. And if you're listening to this on your favorite podcast app, of course, go to the podcast app and that information will be in the show notes there. Mehdi Nahali, thank you so much for sharing your vision and your product with me and my audience. I think that the industry can certainly gain quite a bit of advantage by using something like that. And I can definitely draw the lines to revision control and reliability. I think we don't have to stretch too far to connect those dots. So thank you for sharing, and the best of luck to you, Mehdi, as you expand your software empire. At some point, I'll say I knew him when he just had one product. So keep up the great work, and I wish you again just continued success.
Thank you, Mike. Thank you again for this opportunity. I'm really glad that we were talking about my software, and I'm really glad that I'm creating something to make advantages in the wheel assembly world for companies around the world. What I want is that we create intelligent also softwares for assembly world and make the process more intelligent and more automated. Thank you again, Mike.
Thank you, Mehdi. It was great to meet you. Take care. All right, here are some final thoughts. If there's one takeaway from this conversation, it's this. Reliability isn't just about what happens during printing, placement, reflow, cleaning, or tests. It's about the integrity of the data that defines the product in the first place. Because if the wrong version gets built perfectly, it's still wrong. And that's a wrap on another episode of Reliability Matters. Thanks for being here. Whether you listened on your favorite podcast app or watched it on YouTube, I really appreciate you. If you haven't already, hit that subscribe button so you don't miss future episodes. And a huge thanks to PCB Chat from the Printed Circuit Engineering Association at PCBchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Got a question or an idea for a future episode? We'd love to hear from you. Visit reliabilitymatterspodcast.com. Thanks again for being here. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.